Okay, so today's lesson is on stoichiometry, looking at mole-to-mole ratios. So stoichiometry comes from the Greek word stoichion, meaning element, and metron, meaning to measure. So stoichiometry is looking at calculations about the amount of reactants and products involved in a chemical reaction. So in order to do stoichiometry, we're always looking at a molar ratio, but we can use moles, molecules, or mass, converting to moles, and then using stoichiometry to look at any of these amounts. Balanced chemical equations are super important for determining these ratios, so it's important that you're always starting with a balanced chemical equation. The molar ratio comes from the coefficients in a balanced question. So if I'm looking at this one here, so 2 moles of hydrogen gas plus an implied 1 mole, remember if there's no number there, it's a 1, of oxygen produces 2 moles of water. So if I'm looking at the molar ratio, I could say that it's 2 to 1 to 2. And notice that I keep the same order. So if I start out as my ratio of being hydrogen, oxygen to water, then my molar ratio should also represent that. So therefore, if I want to produce 2 moles of water, I would need 2 moles of hydrogen and 1 mole of oxygen gas. So let's look at another example. So given the chemical formula, nitrogen plus 3 moles of hydrogen produces 2 moles of ammonia. Remember, all stoichiometry, you must start with a balanced reaction, so this one's already balanced for us. If the question asks what is the molar ratio of nitrogen to hydrogen, based on the coefficients in my balanced chemical equation, I would say the molar ratio is 1 to 3. If the molar ratio is asking for ammonia to hydrogen, and notice this time that I flipped the order, the molar ratio for this would be 2 to 3. Okay, how can this actually be used for determining amount consumed or produced within a reaction? So given this equation here, so methanol plus oxygen gas produces carbon dioxide and water. So this is a type of complete combustion reaction. If 3.5 moles of methanol, which is that first compound there, are burned in excess oxygen, how many moles of oxygen are used? So to set up this problem, I first need to have my ratio. So in this question, it's asking if I have methanol and I'm looking for oxygen, I know that my ratio is between methanol and oxygen. In this type of question, you're only ever concerning yourself with two things. The thing that gives you the information, so in this case methanol, and the one that you're looking for, so in this case oxygen. I don't care about carbon dioxide or water for this particular question. The only reason that I needed the full balanced equation was so that I could get the proper coefficients. So then I can set up my molar ratio. So again, that's my coefficients between methanol and oxygen. So it's a 2 to 3. And then I can figure out my question ratio. So my question ratio here would be 3.5 moles of methanol into X moles of oxygen. So I'm trying to solve for X. And I can do so by cross multiplying. So 2 times X and 3 times 3.5. So if I set that up, I would end up with an equation like this. 2x equals 3 times 3.5. Therefore, X equals 5.25 moles. So remember, significant figures still need to be followed for this. So because I started with 2 sig digs, my 3.5 moles, my final answer will be given in 5.3 moles of oxygen being consumed in this reaction. Okay, example 3b. So I still have the same balanced equation, but this time I have 3.5 moles of methanol, same amount to start with, but I'm looking for how many moles of water being produced in this reaction. So this time I need to still start by setting up my molar ratio. I'm given methanol, I'm looking for water, therefore my ratio between methanol and water. You also could set up this ratio between oxygen and water, because remember in the last question we did already solve for the amount of oxygen being consumed. However, I would always suggest going back to the original question data in case you made a mistake in an earlier step. then at least you know that your subsequent questions don't rely on you getting the proper answers earlier on. If you do choose to use the earlier one that you calculated, so that amount of oxygen, always go back to the original value without sig figs. So for that one, I would have used 5.25 moles of oxygen, not the 5.3 that I rounded based on sig figs. Safer bet though is to always just go back to what's given to you in the question. So after I set up the ratio, then I need to set up my molar ratio. Molar ratio again is found by looking at the coefficients in the balanced equation. So it's a 2 to 4. If your molar ratio is something like this that you could reduce, feel free to reduce that. So it would be a 1 to 2 ratio of methanol to water, or leave it as 2 to 4. Either way, you'll find the same answer. And then your question ratio again is what you are given in the question and what you are looking for. So I'm given the amount of methanol, I'm looking for the amount of water. Once I have that, again, I'm cross multiplying. So looking at my ratio, 2 times x and 4 times 3.5. So I found here that if I have 3.5 moles of methanol and it's burned in excess oxygen, so oxygen is not my limiting factor here, I can produce a maximum of 7.0 moles of water.